Hello friends, in the series of our videos, it is on turbine follow mode. We have discussed the coordinated master control in our first video, and then in the second video we have discussed the boiler follow mode. So the turbine follow mode, as the name suggests, that turbine will follow. And turbine will follow what? Turbine will follow this boiler. So in the turbine follow mode, turbine will maintain this throttle pressure. In turbine follow mode, the boiler master is kept in manual. We have talked about those two controllers, boiler master controller and the turbine master controller. So the boiler master controller controls the boiler, as you know. So in the turbine follow mode, the boiler master will be in manual. The boiler master is fed with a manual command. Now in the turbine master controller, a turbine as it follows the boiler. So the main thing of the turbine master is to act after the boiler. First the boiler will do its work and the turbine will then do its work. So in the turbine master, it is fed with the one input signal, that is the difference between the actual pressure and the pressure set point. These are throttle pressure. So throttle pressure is the pressure just before the control valve. Throttle pressure is a pressure, MS pressure just before the HP control valve. So that will be almost equal to this MS pressure with some difference, that is some pressure loss that you will account while the steam gets transferred from the boiler to the turbine. Okay. So turbine master controller will always try to maintain a throttle pressure set point. Okay. So according to the difference, if the difference is more, then it will, if the actual pressure is below the set point pressure, okay, then it will decrease the ESTC input. As the ESTC input will decrease, the control valve opening will be decreased and the actual pressure will increase, and we will reach the set point pressure. However, if the actual pressure set point is more than the pressure set point, then it will open the ESTC. The opening of ESTC will lead to opening of the control valve, which will further lead to the lowering of the pressure, throttle pressure, and we will reach the desired pressure set point. So what we see, that the turbine is increasing or decreasing load, and all this is done to maintain the throttle pressure. So the primacy has been given to the throttle pressure, not the load. The main aim of this control is to maintain the throttle pressure at a constant point. So we have seen that turbine master will maintain the throttle pressure by sacrificing the load. So the first pro is that it will make the boiler stable. With boiler stability, I means that a firing will be controlled. Okay. So as the firing will be controlled, therefore your boiler parts, that are the capital parts of the boiler, will be preserved. Okay, they will no more harm to the boiler. And the con is that you have to sacrifice the load. So you will not be able to maintain the load as per the grid requirement. So turbine follow mode is used when we have just synchronized the unit, because when we have just synchronized the unit, the boiler will be unstable because the heating of the boiler will be slow. Okay, the component will be slowly heated up and they will reach the desired temperature slowly. So there is an instability in the boiler. There will be expansion going on in the parts, and the flame and the other things will be quite unstable at the start of the unit. So at that time, our main concern is to maintain the boiler stable, to make the boiler stable, and this can only be done by the controlled firing. While we have no concern about the load, because if the boiler will be stable, then there will be much less loss. The loss which I'm talking about is the capital loss. It can be of type like boiler tube leakage and other types. Okay, so the boiler stability is our prime concern, and that we are doing with this mode. Okay, thank you guys. Hope you like the video.